Hello, intended audience. Today, we will be going over the derivation of the state space equations. A state space equation is going to be a transformation of any arbitrary order linear differential equation into this general form. This general form is composed of our state vector and our forcing function vector and the A and B matrices. Now, the size of each of these matrices is dependent upon the order of our differential equation. Today we'll be using this differential equation, an example that we worked out in class, as our example. This is a third order differential equation, therefore the A and B matrices will be 3 by 3 matrices, and the the state and forcing function vectors will be 1 by 3 matrices. Now, the first thing that we will write out will be our state vector. The state vector is composed of our 3 states, and each state, otherwise known as x1, x2, x3, is going to be our function, the first derivative of the function, and then the second derivative of the function, since this is a third order equation. Now, each state is technically going to be x1 equal to y times a arbitrary constant. Since this is a mechanical system and it is convenient, that arbitrary constant we will take as 1. Therefore, y is our first state, the first derivative of y is our second state, and the second derivative of y is our third state. Now, since we have x tilde, we can easily derive x tilde dot, which is simply the derivative of x tilde. This becomes very easy. The derivative of y is y dot, the derivative of y dot is y double dot, and the derivative of y double dot is y triple dot. Now, since the state space equation can be given in terms of our states, once we start working with it, we will simply replace this and this with their respective x symbols for states, so x2 and x3, as y dot here would be our second state and y double dot here would be our third state. The only thing in the x tilde dot vector that we cannot replace with its own state would be y triple dot, because it's just nowhere in our state vector. Therefore, we want to write the entire differential equation in terms of y triple dot. And then once we do so, we will replace each of the individual function or derivative values with its respective state, since we are writing the state space equation in terms of its states. Then we simply plug this into the x tilde dot vector to produce this vector. This vector right here is identical to this one. It is simply replaced y dot with x2, y double dot with x3, and y triple dot with this equation. Now, since we have x tilde dot, we can split that via addition and start deriving the rest of the components of our state space equation. We already have the state vector as we derived here. The next thing that we can derive is our forcing function vector. We know that the forcing function vector, u tilde, is only going to be described in terms of our forcing function. And now, that means we simply need to, via addition or subtraction, separate the forcing function within our current x tilde dot into its own vector. So now we have x tilde dot equals 2 different vectors. Where at this stage, we can see that we have this plus, which correlates to this one in the general state space equation, which means that this vector correlates to this one. We'll start with this one then. Since we already know x tilde, or our state vector, we can simply find which 3x3 matrix to multiply by our state vector in order to find our a tilde. As we can see, this correlates there. This is something that you can really, if it's a simple enough differential equation, look at and just kind of backtrack, right? So for the first line, we will have 0, so 0 times state 1 plus 1 times state 2 plus 0 times state 3 equals only state 2. For the second line, we have 0 times state 1 plus 0 times state 2 plus 1 times, oh, that's the eraser. Let's not use the eraser. We don't like the eraser. Plus 1 times state 3, which yields that. Finally, since this is the last one we have minus 4 times state 1 yields minus 4 state 1, minus 3 times state 2 yields minus 3 state 2, and minus 2 times state 3 yields minus 2 state 3. And thus, we have these two individual components, the a tilde and our x tilde that we derived earlier. Next, all we need to do is derive whichever is, in a similar way, roll back the 3x3 matrix, which will multiplying by our forcing function vector will yield this, which in reality is a very simple thing to do because it is simply going to be a 1 somewhere in the vector, since this is just going to ultimately be this. So it's quite a simple derivation, 0 times 0 plus 0 times 0 times 0, 0, all that until we eventually get to just 1 times f of t yields f of t. And suddenly we have x tilde dot on one side of the equation and these two, which yield our original format. So we have our a tilde, we have our state vector, we have b tilde, and we have our forcing function vector.